This slide is going to talk about the rules that I use in my class when discussing how to determine how many significant figures are in a value. You're going to hear me ask that question a lot. You'll hear me say, how many sig figs are there? The first rule is very basic. It says that any non-zero number that makes up a measurement is considered significant. For example, the measurement 14.15 centimeters, that is made up of 4 digits, all of which are non-zero numbers. So if I ask you how many significant figures make up that measurement, you would say 4. Now the second rule is probably the most important, and it's the one that students screw up the most. And it's a rule involving zeros. It says that zeros are significant when it comes at the end of a number and a decimal point is present. For example, let's take these numbers, 120, 120.0, and 0.0120. All of these numbers have zeros in them. Some of the numbers have zeros that are significant, and some of these numbers have zeros that are not significant, and one of these numbers has zeros that are both significant and insignificant. Let's talk about each one separately. The first one I'm going to talk about is 120. Now 120, a couple of non-zero numbers, 1 and 2, but the question is this zero significant? Well, it may come at the end of a number, but it's not present with a decimal point, and so the zero is not significant. If I ask you how many sig figs there are, you'd say there are 2 sig figs here. Now this next one, I have, once again, 1 and 2, and then I have a couple of zeros. Now this zero at the end comes at the end of the number, meaning furthest to the right, and a decimal point is present. So that means this has at least 3 significant figures, but in fact, this one is significant as well, because they both come at the end of the number. Not just the 1 0, but all zeros at the end of the number when a decimal point is present makes them significant. So you would say that this has 4 sig figs with it. Now finally this one. Now we've got some zeros, and we got at the beginning and at the end. So this one's significant, this one's significant, and this one is at the end of a number and a decimal point is present. Now this first zero, the one in question, comes at the beginning, not at the end. So it's not a significant figure. So if you're counting sig figs, this has 3 sig figs and not 4. It has 4 digits, only 3 of which are significant. So if I zoom back out to look at the entire slide again, I'll give myself some room to write in number 3. This is the rule with zeros, only when they come at the end and a decimal point is present. Now you may be familiar with AND statements versus OR statements, but an AND statement means that both of these statements must be true in order for this to occur. The zero is only significant when it's both at the end of a number and a decimal point is present. Now rule number 3 talks about sandwich zeros, which are zeros between significant figures, what I like to refer to as the sandwich rule. That's not really a technical term, but that's what I call it. It says that any zeros that are sandwiched between significant figures are also significant. So for example, you've got the number 102 or even 100.01. All of these zeros that are sandwiched are significant. So that means that there are 3 sig figs here. And then on this one, you've got 3 sandwich zeros. And it doesn't matter how many zeros are between non-zero numbers, they're all significant. So that means that there are 5 sig figs in this number. Now you might be asking yourself, how in the world can some of the zeros be considered significant while others considered not significant? And it has to do with how the measurement was taken. I'm going to go back to my 2 examples that I had before. Let's say that you have 120 milliliters and 120.0 milliliters. Now I'm going to hopefully illustrate this point using an example of actual measurements. Let's take, for example, the first number, 120 milliliters. Well, this is not likely to be the case, but this is how this would occur. What if you had a graduated cylinder that only measured every 100 milliliters? If that's the case, all you see is markings at the 100 mark and the 200 mark. Because I've taught you about how to take accurate measurements, this person looks at the graduated cylinder and says, I think it's between 100 and 200, and I estimate the last place value to be 20, or essentially 1/5 of the way between 100 and 200, so I call it 20. Now they can't call it 21 or 22 or 23 because they don't know where every whole number is. Remember, you can only report your answer between 2 numbers and then estimate the last place value. So you can only report between 100 and 200 and then estimate to the tens place. So that's how that number came to exist, from an instrument that wasn't very precise, but the number is measured properly. Now let's talk about 120.0. This particular person walked up to this graduated cylinder and saw what you see in front of you. You have a graduated cylinder that marks every milliliter along the way. And they measured the blue line to be touching the 120 line. So it's not 121 or 122 or even 119. So they measured it to be 120. And then they estimate the last place value. And since it's touching the line, they have to say 0.0. Now, if it's slightly above the line, they would say maybe 120.1 or 120.2. But 120.0 is an exact value. It's saying that it's touching the line. It is precise. It is exact. This 0 in 120 came from an imprecise instrument. So my answer reflects the precision of the instrument I used. When I look at 120, I say to myself, well, the number's probably done or measured correctly. They just had a poor instrument. Where if I look at 120.0, I say, this number is much more exact because they had a better instrument. They're not, neither of which are wrong. It's just the number on the right has more significant figures, which means I can be confident, or I can have more confidence in that number as being more exact. That's the whole idea behind significant figures, is how confident when you see the number can you be in that number based on the number of digits the measurement used. Now there's one quirky situation that I want to talk to you about when it comes to significant figures. If you ever come across a number with a 0 in the ones place value, you have to take a close look at what is right behind it. Because a 0 in the ones place value followed by a decimal point is significant. 10 point. Now you've been told your entire life that when you report a number with a decimal point that you always follow it up with a 0. But we don't do that in chemistry. We don't necessarily put digits in because the instrument may not allow for it, in fact. And so if you want the 0 to be significant, but you don't want to add any more significant values because they technically don't really exist, you put a 0 in the ones place and follow it by a decimal point. This only happens maybe 1 or 2% of the time, but it is a quirky situation that you have to look out for. It is a thing, and you need to know how to apply the significant figures appropriately. This number is made up of two significant figures. This number is made up of 1, and this number is made up of 3. All of them are equivalent mathematically, but they all have different levels of precision. They both are different layers of exactness. And all three were gathered with different instruments, different precisions of different instruments. I'm going to tell you how to handle significant figures when you have a number in scientific notation. Remember, scientific notation is used when you have a very, very large number or a very, very small number. An example being like the number 1.30 times 10 to the 8th kilograms. If you expanded that out, you would have 130 with 6 zeros after it. Let me double count those. That indeed is correct. So this number is astronomically large. It's huge, but we would shrink it by using scientific notation. When using scientific notation, you have to decide which of the numbers are significant and which ones aren't. Now I expanded this number out, and with no decimal point, none of these zeros are significant. But up here, I'm going to go back to this original number, 1.30 times 10 to the 8th. In scientific notation, only the numbers before the times 10 are considered significant. And that's always the case. And so in this example, 1, 3, and 0 are all significant values, so that's 3 sig figs. The times 10 just tell me that this number has been expanded out very, very large, but the only significant values I want to use are the 1.30. So whenever you see a number with scientific notation, just count the numbers before the times 10. So we're going to finish up with counting significant figures here. We're going to take a look at each of these examples and talk about whether or not the zeros are significant or not. This first example, the first 3 numbers are significant because they're non-zero numbers. The zeros are at the end of the number, but there's no decimal point. So in this case, there's only 3 sig figs. The next example, again, you've got a number that has some zeros at the beginning and some zeros at the end. Only the zeros at the end count if a decimal point is present. So 4, 5, 0 are significant, and the first 2 are not. The next example, We've got a 0 between two non-zero numbers or two significant figures. That's the sandwich rule. So this again has 3 significant figures. This next example, 9 and 3 are significant, and the last one's significant because it's at the end and there's a decimal point. And this is also sandwiched and at the end, so you consider these all significant once again. Moving along, we've got a number with zeros at the beginning and at the end and sandwiched. We got zeros all over the place. Of course, the 3, the 0, and the 5 here are significant. So are the zeros at the end because they're at the end and there's a decimal point. So 1, 2, 3, 4, 5. But the first 3 zeros are not significant, so just 5 significant figures. Next one is scientific notation. We just talked about this. You have a number in scientific notation. Only the numbers before the times 10 count as significant, so those are 3. And finally, I come to this example, 12 eggs. Now, since eggs aren't something you can gather, information you can gather with an instrument, you're just simply counting items. We say 12 eggs has an infinite number of significant figures. That takes care of this introductory video lesson on how to count significant figures. I hope you enjoyed this. Thanks for listening.